we at ECP believe we have developed is an ideal pump set. It's a self-priming unit complete with what we call a hydrostat. The hydrostat is mounted on the self-priming pump, which is the silver object, which is resting on the pressure vessel. Normally the hydrostat, which is the black device on the top, is mounted directly onto the pump, but with the addition of the pressure vessel it reduces the amount of times the pump starts and stops. We call it cycling. Now on this setup for this test pump, we've got the pressure already up, and if we look at the pressure gauge here, they're showing approximately 4 bar. Okay, now I'll open the valve, the isolation valve. You can see water's coming now, not from the pump, but from the pressure vessel. Now, normally without the pressure vessel, the pump will start up. Now we can hear that it is actually started up. Okay. Now the advantage of the hydrostat is no matter how much the valve is opened, the pump continues to run without this cycling, starting and stopping, which uses electricity, of course, and also wears the pump and bearings and the seal, and can also cause water hammer. Water hammer is where banging in the pipe work is noticed, and pipes can swing about. That itself can cause problems, but that is the advantage of the hydrostat, or one of the advantages of the hydrostat. There's no water hammer. Right, now just close the outlet valve. Now we'll see the pressure rises nice and gradually, building up to what the maximum the pump will generate. In this case, approximately 4 bar. 4 bar, as you'll notice from the gauge, is approximately 60 psi. We generally say mains pressure is 3 bar. We always try to mimic mains pressure. Now you'll notice once this cylinder has recharged itself, the hydrostat runs for about 9 seconds, there we are, and then shuts down. Did you notice without any water hammer whatsoever? Now it's just dropping back slightly. It's because it's just moving into the pressure vessel. The pressure, I should mention, the pressure vessel has a rubber bladder or diaphragm inside, and air is deliberately trapped inside the vessel. Right, now I'll open the valve again. Update the flow this time. Let's do that. We'll open it to about 2 bar. Now to put things in perspective, 2 bar is equal to a water tower 20 meters high, 66 feet, just to give you an idea of pressures. Now we can see the flow with this particular pump, decent flow, 2 bar. Right, now one other interesting feature of the hydrostat is, I'll try to do it over here. I'll pull the pump suction hose out of the water, and here it's suck air. Right, and here it's lost its prime now. And what will happen is the pump will try and pick up, but it may shut out on the hydrostat, which it has done. We can see the failure light. So when that happens, simply push the reset button, and the pump will reprime itself. Depending on how far the suction pipe is from the pump. May have to be pushed more than once, or it can even be pushed continuously until it's picked up. There we are, and it's picked up. Marvellous. That means it's just the air passing through the system. Right, I'll just show you, as the pump is a centrifugal pump, the higher that air is, again that will pass. With a centrifugal pump, the lower the pressure, the pump pumps more. And of course, the higher the pressure, the output decreases. So let's just close that to just under 4 bar. Right, and I'll close the valve fully actually. See by the handle. But what it's doing now is charging up the pressure vessel. It's nice, and you can imagine this in real use. It just takes a while to charge up the cylinder. Right, okay. Now I've just cracked the valve slightly. Just move down to here. This would be the equivalent really to a toilet bowl valve in the toilet system shutting off, or the tank, if there is a tank, in the overhead loft. I should mention that's one of the advantages of this type of pump. No overhead tank required. The end result is the pressure and flow as good as or better than the mains. If you have many sites where the mains pressure is extremely low. And you see, all this water's come off and the pump still hasn't started. Just move back up here, try not to get you dizzy. Right, now this, I've just moved to the hydrostat. This hydrostat is unique in so much we have an adjustment screw here to adjust the cut-in pressure. Normally they're factory set at 1.5 bar. Let's just go back to here, and it should cut in soon. There we are. Now, depending on how much the valve is opened, I think I've got it open sufficient, it will continue to run. I should mention this system is ideal for reverse osmosis. Reverse osmosis, which we specialise in, is an under-sink filtration system which will remove any form of contaminant, nitrates, lead, copper, pesticides, all that sort of thing. As it fills the vessel up, when the water passes through the membrane, fills the vessel up relatively slowly. And this idea this system is ideal for that situation. The water is coming from the pressure vessel, not from the pump. I believe we at ECP are the only company assembling units such as this. Of course, we can make up any type of unit, and that's what in fact what we do specialise in. In fact, one of our slogans is "You name it, we pump it." And we do make up factory sets. Right, you see, just running around at 4 bar. Just go down to here. So that normally, if it was pressure switch controlled, it would have cut out and then drained down and cut in again. It's this starting and stopping that uses electricity. And of course, pipeline surges and also electric surges. The lights will dim and cause, if you're a hi-fi enthusiast like I am, it causes spikes in the electric supply, which could be interpreted as sparks across the contacts. So it could induce sparks into the electric supply. Well, I think that's sufficient. Let's just let it draw air again, where we can see the benefits of the self-priming pump. Right, now I've lifted the pipe out of the water. Here we are, it's lost its prime. Just go back to here, so the gauge should drop down. Okay, well of course I've still got it restricted. Let's open this a bit. There we go. Right, but she's cut. Notice I use the feminine, all pumps are she's. She's cut out, so let's push. Oh. Right, now it's got the prime itself. Possibly the failure light will come on. No, it's picked up, so it shows how good the pump is. Right, well this, I've lifted the hose out again. Let's just see it shut off on fire. There we are, it's starting to glow. Oops. Right, that should shut out and shut down soon. There we are. So the fail light is on. So just put the hose back. Now to reset it, because it's obviously lost its prime. You can just try sometimes one push, but depends on the length of the suction or distance. Right. So we just hold that till it picks up. Now of course, what I should mention really is the combination of length and depth. If the water level in the well, for example, is quite picked up now, so we release. If the water level in the well is quite a way down, or quite a distance, for example, even pumping from a stream or a well, the pump doesn't necessarily need to be over the well, it can be offset. Sometimes even 50 metres or 100 metres. But we always say the closer to the water the better. Right, well we can hear it's picked up. Let's just look at the flow. Perfect. Now what I will do, just to empty the system, that is the air. I'll just let it drain down, and we'll just let it cut off. There we are. It's cut off and the failure light should be on. Right, I'll just switch that off electric supply. I should mention this pump also, we've put a check valve here. Normally it would have a foot valve on, but on this particular site there isn't room for a foot valve. The client's actually pumping direct from the borehole. Now I'll just disconnect these hoses so we can see. It does look a bit intimidating what we've got here, but in fact this is, see, we've used these special, we call them cam lock couplings, right, and this is the pump by itself. I should mention we have a union here on the hydrostat, so we're able to loosen this off and this can swing around to suit site conditions. Okay, should also mention this pump is single phase 230 volt. Just quickly move over to this other set that we're in the process of building up. Right, this one here is 12 volt DC. Again, we're going to build this up for another client. Okay, hope you've found this informative, and remember, if you need a pump or borehole or well or water treatment, to contact us at ECP. Our website, ecpgroup.com, our email, sales@ecpgroup.com. Thank you.